Hi all, I am Dr. Kalaavathi, Professor and Head of CSE Department. In this lecture, we are going to see MANET, which is a special type of network, particularly a wireless network. This network is called a MANET Mobile Ad Hoc Network. Mobile Ad Hoc Network, basic feature of Mobile Ad Hoc Network is it doesn't have any fixed infrastructure. We might have come across different major two networks. One is infrastructure based network, another one is infrastructure less network. So this MANET Mobile Ad Hoc Network is basically a infrastructure less network where we don't have any fixed infrastructure or what we call it as a base station. So in that case, every node is going to act like a router and a node by itself. So what happens whenever any node wants to send data to somebody, it receives the data and it forwards like a router. So that is a basic principle of MANET. So this kind of MANET are used in emergency cases where we cannot go for constructing any sort of fixed infrastructure. Particularly in emergency cases, in military and all we use MANET Mobile Ad Hoc Network. So in the MANET, the routing is a difficult task. Because we don't have any fixed router, the routing is a difficult task. And the basic two major types of routing in MANET is, one is what we call it as a proactive routing algorithm, another one is reactive routing algorithm. So in case of proactive routing algorithm, what happens in the sense, every node keeps on updating its own routing table regularly at periodic intervals. So what happens if there is any data transmission or not, every node keeps on updating its own routing tables. So the advantage in case of proactive algorithm is the routing table is always ready with the latest information, but the major disadvantage in case of proactive routing algorithm is all the nodes in our MANET are battery operated nodes. So what happens, the battery of every individual node is wasted only for maintaining all the routing tables even though there is no data transfer. So that's why we don't normally prefer proactive routing algorithms. The second category of algorithms are reactive routing algorithms. When there is a need for data transfer alone, that time we go for route finding or route discovery. So in that, major two algorithms are there. One is called DSR, Dynamic Source Routing Protocol. Another one is AODV, Ad Hoc On Demand Distance Vector Protocol. Basically, a reactive protocol works in two principles. The first thing is, whenever there is a need, it looks for whether there is a route already available or not. If there is no route at all, it goes for the first step, route discovery. Every node, whenever it wants to send data, it starts with the process called route discovery. If the route is found, then it goes for data transfer and then it has to go for second step, route maintenance. So these are all the two major steps in case of any reactive routing algorithm. These two are the major two steps. One is called route discovery, another one is route maintenance. Now we'll look into one major reactive routing algorithm, what we call it as dynamic source routing. I'll tell you why it is named as source routing. We'll take one example of network where the number of nodes are there. We'll assume S is our source node and D is our destination node. So when S wants to send some data to D, it looks into its routing table whether there is any entry for destination D. If there is no entry available in a routing table, what it does, it starts sending a kind of broadcast information. Normally we will call that as flooding information. It floods the route request information. Flooding happens from a source node. So what happens in the sense, the source node starts sending a request image. We will call that as route request image, RR request, route request. That message will be transferred by the sender when there is no route in its routing table. So what are all the contents in a route request is, there are two major information. One is called a unique ID. Another one is to whom it wants to find the route. Probably the destination will call. So what happens whenever S wants to send a data, it sends a root request. So the root request is received by all its neighbors. So the neighbors for S are A, B and C. So all the three neighbors will receive the root request. So once a root request is received by the neighbor or any node, the node does three things. Every node, whoever receives that particular root request, it does three things. The first thing is it checks whether that message is a new one or it is a already received message. With the help of ID, the ID for each and every outgoing message, it looks for the ID, whether this ID is a new ID or it is already received ID. If it is a new ID, then each and every node checks whether the destination address matches with its own address. If it matches, then it stops the process, then it gives a reply. Otherwise, if the destination address does not match and the root request message is a newer message, what happens? Every node appends its own address and broadcasts that message further. So that's what we call it as a flooding. Broadcast happens in step by step until at a particular level. We can limit the flooding to any limit. Either it can be normally half of the diameter of a network. That is the normal standard case we used to assign for our flooding level. So in this example, when A receives root request, what it identifies, it is a new message. So and A is not the destination for this root request. In our example, S will give a root request and ID, let it be ID be 10 and the destination is D. So here once it is received by A, B and C, all the three neighbors, they won't give a reply. They identify this message is intended for someone else. So they will again forward it, they will again broadcast to its neighbor. So what happens? A further broadcasts this root request with its own ID. I will write down here root request. 10 is the ID number and it is passed via A and the destination is D. So every node, whoever passes this root request, it appends its own address. So what happens at C? C is going to add its own address. B is going to add its own address. I will write the address part along here. So B will add its own address and C will add its own address. And again it will pass this message. So again, whenever A retransmits again, who are all going to receive this particular root request in the sense? Its neighbor or all neighbors of A will receive that broadcast message. Who are all A's neighbor in the sense? S, G and E. Obviously S will not process that information because that S is the source. And G and E will process. We'll hope E has not received that message from B. And B will also rebroadcast the message from S to its neighbor. Its neighbors are E, F and H. So all these E may receive either from A or from B at first. If it receives from A first, it processes only that message. If it receives from B first, it processes only that message. It rejects the duplicate message. So likewise, it keeps on passed to neighbors and neighbors until it reaches the final destination. So we will hope S to B and B further broadcast. So what happens? The path is B to B, S, B and F. Likewise from S, C, H and F to B, F to K. So what happens? K in turn directly again forwards to D and L also going to forward to C, H, L, that is forwarded by L to D. So it has started from S, S to B, B to F, F to K and K to D. K can receive either from D can receive either from K or from L. So what happens? Once D receives the root request message, it is going to give a kind of root reply. So the root reply will assume it goes this path. So the path is S, C, H, L. So this path is preferred by root reply and the source root, the source node completely knows the path. That's why it is called source routing. So and this kind of routing is taken place whenever there is a demand. That's why it is called dynamic source routing. And for every outgoing data packet, the source node appends the complete address which is found in our root discovery phase. In our example, SCHL, that route is passed by the source node in every outgoing packet. So that's why this kind of algorithm is called dynamic source routing protocol or routing algorithm. And this kind of algorithm is particularly useful since it is a reactive routing protocol, and we can do some kind of optimization in this routing protocol. You might have seen something. Whenever any intermediate node passes the root request message, they can also learn the route of its neighbors. So that is another major advantage of your DSR. So DSR is a dynamic source routing protocol, and it is a one kind of routing protocol for mobile ad hoc network. And this DSR makes use of one basic principle, what we call it as a source routing. Why we mean this as a source routing, in the sense every outgoing packet will have a complete route information from the source to the destination, which is found using the route discovery packet and route reply packet. I hope you all might have heard this dynamic source routing, and I hope this video will be useful for you. Thank you.